array is 3, right? So that means in the worst case, the smallest missing positive integer in the worst case, right? The largest it could possibly be is going to be 4. Why is that? Why is it going to be 4 in the worst case? Well, take a look at this. What if the input array we got was 1, 2, 3, right? Remember, the size of our input array is limited to size 3. So in this case, if we had 1, 2, 3, then we know that n would be 4. The result would be 4 because we're missing the smallest positive integer we're missing is the 4 that would go here, right? If, for example, we did not have all 3 of these, right? Maybe we're missing that 3 like we had previously, then we would have the n equals 3, right?
Is there duplicates in this problem or no?
I haven't seen.
Are numbers distinct? I thought of a solution, but
You
I'm
could
not sure.
store them as well, you know. if
You
that's
said
an
what
issue.
happened? Oh, if it's set,
just-
yeah, it's only Ovid. You're right. I gotta think about it more. I'm not sure. Does this work? Memory limit. Damn.
Right? Or for example, maybe we would be missing a 2, right? Maybe we have 1, 2, 3, 4. Then in that case, we'd have a 2 that goes here, right? 2, 3, 4. Then in that case, the smallest missing is going to be 1. But basically, no matter how you arrange this, right? Maybe we would just have really big integers. For example, 10, 11, 12. What's the smallest missing in that case? Again, that's just going to be n equals 1, right? So basically what I'm saying here is no matter what our input array is, no matter what the values go in it, the answer, our result, n, the smallest missing positive integer, is going to belong to the set between 1 and length of the array plus 1. That's pretty obvious, right? That's mathematically obvious, right? We could not have a smallest missing positive integer that would be larger
How about
than
this?
this.
How about this? I think that's what we did before. Hear me out. Hear me out.
All right, I'm listening.
Are you watching the video? Is that what you're doing?
I got to only 4 minutes. He hasn't really said much.
Oh. So how about this? Every
I'm
time.
listening.
So like for this one here. Let's say we put this in an array. We put this in in a set. All right. We put 1 in a set. Then we see if there is a number before 1 that is not greater than 0.
A number before 1. Doesn't that like? But what if it's not in order? Will that mess anything up?
Yeah. We need to start at 1.
Yeah, because if you sort it, it's easy because it's just n log n. But that's doesn't work. Honestly, bro, like they said, it's an elite code hard for a reason, man. Like, we could probably watch the video, learn something new, and then move on with our lives.
But is it worth learning? It's an array and a hash table. I don't know if this is worth learning because I'm just gonna forget it.
I mean, but like, I don't know. I'm kind of curious.
Okay.
If you go to the video and go to 425, like you can just probably start there. He just kind of explains the problem. We can start
What
there.
video is?
It's on here. I'll send it to you. Sent.
Our input array is just, limited in size. We could not have a missing positive integer.
Hey everyone, welcome back. Let's write some more neat code today. So today let's solve first 1, right? So basically what I'm saying here is no matter what our array is, no matter what
the headphones going through your speakers? I gotta hear the video like I'm playing it. It's mute yourself. Cool.
On the length of the input array. So in reality, we actually don't need to sort this input array. We can actually take the input array, convert it into a hash set. Why are we converting it into a hash set? Because we're going to brute force this. We're going to go through every single value from 1 to n plus 1, right? Or the length of the array plus 1. So we know the solution belongs to this. We're just going to have a for loop that goes through all of these values, tries each of them, right? So for example, we're going to try n equals 1. We're going to check, does n equals 1 exist inside of our hash set? And we can check that in O of 1 time, right? If it does exist in our hash set, then we're going to try n equals 2, right? If that exists, then we're going to try the next number, right? N equals 3, so on and so on. If n equals 3, for example, does not exist inside of our hash set.
Wait, I can't hear you if you're talking. You muted.
Once again, hear me out. I was saying I was gonna say this before.
Uh-huh.
Like, why don't we put that array in a set and then count from 1 and say if this thing is in there, then we keep going until it's not.
I think that's literally the answer. I got to that part too, and I was like, "Damn, this is so simple."
But would it time out for that?
You want to stop and just try it? Because, like, honestly, I don't know. Do I really want to watch another 15 minutes of this?
All right, I'll try real quick.
Yeah, let's go back. I think we do in C++ too. Get rid of this malarkey. All right, let's make these comments. All right, so first, make a hash set.
Why do we have to write comments for this? Like, this is simple. It's like 3 lines, bro.
And yeah, until you start getting errors and you'd be like, "Oh, what's wrong?" like we've all been there. And if it's so simple, the comment should only take 30 seconds.
Wait, how do you make a set?
I think it's like set. It's like set, man. And you put the int, like it's like ints like that.
No, I mean, but like, how do you put the nums in the array?
So you just add.
So you do like 4.
Oh, because there's no range. Oh, man, you just gotta make a counter and get the max element.
Put everything in there, right?
A counter.
What?
Like, oh, I mean, there's no range, so just use a for loop that goes up to the max number. What the length of nums? I think it's like 4. Mint I 1. Plus 1. 5 plus plus. Contains the thing?
That's what my note says.
I didn't even know. I thought it was count. Is that just a set thing, or is contains for arrays too, and hash maps?
Set?
Only? It's a special thing only for sets.
Let me check array.
Isn't like Python? We just got as. We could use that or in.
Yeah, I don't see that in arrays.
Yeah. All right. Contains. So count for vectors and hash maps and contains for. Okay.
It also has find and as you know, count.
Well, so it does have count, but so it contains a special thing just for like.
I don't know the difference between contains and count. It says so returns 1 if the element is present, returns 0 if it's not. Oh, okay.
Isn't that what count does?
No, that's what the definition of count is.
Yeah. Oh, so what does contain do?
We're gonna find out.
Sky, we're gonna find out. Okay, understandable.
For existence, so I guess it's gonna return true or false too. I don't know.
It seems like is there like a difference? All right, I'm gonna say contains versus count. Here's that Geeks for Geeks article. Oh, it says count returns the number of times an element appears in a set.
Makes sense why it's named count.
Since sets store unique elements, count will always return 1 if the element exists or not. It's commonly used to check existence, but it may be less efficient than find for large containers because it continues searching even after the first match is found. Find returns an iterator pointing to the element if found, or the last element if not found. It stops as soon as it finds the first match, making it more efficient in terms of performance, especially for associative containers like sets and unordered sets. Contains, available in C++ 20, is the most intuitive and readable method to check if an element exists. It returns true or false clearly, expressing intent, and is equivalently performance to find, but avoids the need to compare with the end. Yep, so contains is the new guy on the block. Don't use find. Not good, not good. Like C++ gives you too many options.
Does it really?
Contains, count, and find? Do I really need all of those? Alright, I get count, but contain, like when they added contains, like you should get rid of find. And this whole you can't print a vector, nums.begin, nums.end. There's no sum. You gotta put accumulate, nums.begin, nums.end. This works. This is criminal.
Fuck yeah.
Yo, it's so slow. What the fuck? How is this so bad? Is this not like O of 1, O of n time? Am I tripping? A set O of n. Alright, hold on. Okay. Big O of n to make a set, like, clearly. Nums, that's just big O of n too. Like, that's fine. Oh. Small O n. Looping through nums of size? That's just 3 big O's. How is it so bad?
Mm-hmm. I assume, yeah, I don't know.
Maybe it's one of those things where you just run it again, then, you're cooling.
Probably.
Wait, let me comment this out real quick and run it again. Just want to see if it does any better. Nah, it's still just as bad. All right. This is like the top solution.
Mm-hmm. There's a swap function. Did not notice.
You didn't know about that? It's kind of cool. Like you could just put 2 things in there. It'll just swap them instantly. There's no temp variable. Nothing. It works on arrays. I used it a couple times. It works on maps. Anything that like stores a reference, it'll just switch there. What each one points to. Wait, what? Do you get this part? Like, what are all these checks for?
Like equivalent to like in place swapping, right?
Yeah, it's literally that's what it is.
Is there any other way?
Wins in one thing.
I don't know if that's a win because we could do this also in one line.
But you gotta do the whole equals thing. They can like have like extra. It's like actually, this is less code.
What do you have against equals? This is literally more
Why?
code than
No,
typing
it's not. You would have to go equals and then copy this over and then put this over here and reverse it. That's longer. Let C++ get a win, man. Like,
No,
that's a win.
no.
Think about it. You don't have to make a temp if you want to swap. Like, that's a win. Maybe it loses in everything else, but you know, swapping, you save like 0.3 nanoseconds.
Okay.
All right, so what's up with all this? If the nums is greater than n, if it's greater than n, then that means it's a valid number. If nums of I,
set, then we're going to return n equals 3 as our result, the smallest missing positive integer. If, for example, we go through the entire loop and we don't find any value, so for example, if we tried the n equals the length of the array, and even that was found in the hash set, then by default, we're going to return n equals the length of the array plus 1, right? This is our worst case scenario. This is the largest it could possibly be. And so since each of these operations just takes O of 1 time, and we're doing it for every value based on
So basically, this if and this else if does the same thing because they. So you could literally combine this and this. I guess they did it to make it cleaner because it just doesn't make any sense. They both equals the same thing. So
yeah, I
do
thought it
that
was
if
weird.
or else. You see, I think what this is doing it probably is like ordering in place or as you go up. Does that make sense?
Dude, I just learned, dude. I know why our thing is so bad.
Go on.
Inserting into a set is log n time. And every time you run
Yeah.
contains, it's log n.
Oh. Which one contains not log n?
Like, I don't, wait, what do you mean? Wait, which one doesn't contain log n? Contain is log n. And we do it n times because you're checking it. So it'll be n log n. This is
Yeah,
just as bad as sorting.
Yeah, but I'm asking, is there like a method that checks within a set that doesn't take
Oh.
n log n time?
Nah. Because it says that internally a set is a balanced binary tree. Or binary search tree. And the fastest way to find something is log n.
Because if we did this in Python, it's all one time, right?
Oh shit, no. Remember unordered set. Remember? Because if you use map, like it's the same thing. We gotta use unordered set. Remember that video I sent you? Your codes may be running slow because of this, and he showed the car?
Yeah.
Yeah, it's about the unordered set, man. I think that's how you do it. There we go. Now you get those O of 1 grabs. This might actually be way better. Okay. Come on. Oh, man. It's like a lot better. It's not the best. It's a lot better, though.
All right, we're slowly climbing up there. Yeah, totally. For sure.
Don't use set. Unordered set. Okay. The more you know. Don't use
I'm
map
just
either.
gonna delete this from my notes.
Wait, we delete what? Oh, because like that's all for like a set. Okay, understandable. Yeah, I don't know why you'd ever use like a. I've never found a reason I'd need an ordered set, but you know, whatever.
Okay, bro, I'm gonna go get my lunch now.
Oh, all right. That was actually pretty good. We solved the hard problem. I take those.
Yes.
All right. Well,
All right.
peace, man.
Yes. Till next
You
time.
getting back on later? Or are you done until tomorrow? Oh shit, he's gone. Yeah, there you go until tomorrow. All right, boys.
on the length of the input array. This is going to be 1 times n. That's just big O of n time complexity. But the hash set is taking extra memory, right? So that's going to be big O of n memory as well. But we can use this to our advantage. We can devise a way where we actually don't need a hash set. How can we do that? Well, we are going to need some extra memory, but it turns out we can use this input array as that extra memory, so it doesn't actually count as extra memory. So we can take this time complexity, or this memory complexity, big O of n, and reduce it all the way down to big O of 1 by using the input array as our extra memory. So like I said, we're going to be using the input array as extra memory. Just like we used like an extra memory hash set, we're going to basically be using our input array as a hash set. How am I going to do that? Remember how our solution set is basically from 1 all the way to the length of the array plus 1, right? This is our solution set between 1 and the length of the array plus 1. So for every value between 1 and the length of the array, right, we have an index for that, right? So 1 is going to be mapped to the 0th index, right? 0 index, 1 index, 2 index, 3 index, right? The last value, length of the entire input array, is going to be mapped to length of the array minus 1 index, right? So in this case, we can see the length of the input array is 4. So 4 minus 1 is going to take us to this index, right? So each of these values has a position in the input array. So how am I going to use the input array basically to tell us, for example, if I want to know in constant time if the value 2, right, the value 2, does 2 exist in our input array? How can I know that in constant time? The way I'm going to do it is I'm going to say, okay, we want to know if 2 exists. I'm going to take 2 minus 1, right? That's going to give us our index value. I is going to be 2 minus 1. We know that evaluates to 1. So we're going to go to the 1 index, right, which is over here. This is 0. This is 1. And we're going to go here and we're going to check, is this value negative? Negative tells us that 2 exists in our input array. We don't know where it exists, but we know that 2 does exist. We can figure that out in constant time, right? So we're going to use
Bro, what? In tarnation? Are you talking about? Doesn't that work? It's not sorted though.
Just one problem. It turns out that this input array that we're given can have negative values by default. So how am I going to handle that? Well, it turns out we're looking for the smallest missing positive number. Obviously, by just looking at this, we know that that's
he lost me here. What?
So how can we do that? Well, we are going to need some extra memory, but it turns out we can use this input array as that extra memory, so it doesn't actually count as extra memory. So we can take this time complexity, or this memory complexity, big O of n, and reduce it all the way down to big O of 1 by using the input array as our extra memory. So like I said, we're going to be using the input array as extra memory. Just like we used like an extra memory hash set, we're going to basically be using our input array as a hash set. How am I going to do that? Remember how our solution set is basically from 1 all the way to the length of the array plus 1, right? This is our solution set between 1 and the length of the array plus 1. So for every value between 1 and the length of the array, right, we have an index for that, right? So 1 is going to be mapped to the 0th index, right? 0 index, 1 index, 2 index, 3 index, right? The last value, length of the entire input array, is going to be mapped to length of the array minus 1 index, right? So in this case, we can see the length of the input array is 4. So 4 minus 1 is going to take us to this index, right? So each of these values has a position in the input array. So how am I going to use the input array basically to tell us, for example, if I want to know in constant time if the value 2, right, the value 2, does 2 exist in our input array? How can I know that in constant time? The way I'm going to do it is I'm going to say, okay, we want to know if 2 exists. I'm going to take 2 minus 1, right? That's going to give us our index value. I is going to be 2 minus 1. We know that evaluates to 1. So we're going to go to the 1 index, right, which is over here. This is 0. This is 1. And we're going to go here and we're going to check, is this value negative? Negative tells us that 2 exists in our input array. We don't know where it exists, but we know that 2 does exist. We can figure that out in constant time, right? So we're going to use negatives to determine that. Just one problem. It turns out that this input array that we're given can have negative values by default. So how am I going to handle that? Well, it turns out we're looking for the smallest missing positive number. Obviously, by just looking at this, we know that that's going to be n equals 1. That's going to be the result, right? But we're looking for an algorithm to solve this problem. And it turns out that negative numbers are useless to us. We don't really care. If I took every negative number inside this input array and just crossed it out, it would not matter, right? So that's exactly what I'm going to do. I'm going to take every negative number, for example, negative 3, get rid of it, replace it with a 0. Why am I doing a 0? Why don't I just replace it with a 1, right? Well, in that case, if I replace it with a 1, I just changed the entire input array, right? Remember, the solution to this problem is n equals 1. If I add a 1 to this, then I've changed the solution to n equals 2, right? We don't want to do that. That's why we're giving it a neutral value of 0, right? I'm replacing every negative value with a 0. So it might be a little messy, but let's just assume that this has been changed to a 0. So we're going to basically scan through the entire array, change every negative value to a 0. We can accomplish that in O of n time, and we're actually going to be needing to scan through the entire array 2 more times, so it's overall going to end up being 3 times n, but that's still linear, right? That's still going to reduce to big O of n. And since we're not using extra memory, we're using the input array as extra memory, the overall memory complexity is going to be big O of 1. So now what I'm going to do is I'm going to start at the beginning of the array again, and now is when I'm going to start marking values as as appearing in the array. For example, 3, right? We have a value 3. We want to mark that 3 exists in our input array. So what we're going to do is we're going to go to the index I equals 3 minus 1. That's index 2. Index 2 is over here, right? And we're going to change this value to a negative value if it's not already negative. Right now we see that it's positive, so what we're going to do is we're going to change it to negative, right? So we're just going to add a negative sign. This is going to be negative 6 from now on.
Wait, what the actual
right?
target?
So we are changing values, right? So it turns out that it's possible that this also could have been a negative 3, right? So basically every time we get to a value, we're actually going to be taking the absolute value of it, so absolute value of 3, and then minusing 1 to find the index. So since index 2 is negative, we know that 3 exists in our input array. Next, we're going to go to this value. It's 0, right? It turns out I equals 0 minus 1, that's going to be negative 1, right? That's out of bounds of our input array, right? That's going to be over here, right? That's out of bounds. So we're not going to be filling values that are out of bounds. So it turns out this is out of bounds. We're not going to fill it. Next, we get to the value 6, but remember, this is negative 6 now because we changed it. So we're actually going to have to take the absolute value of this. Absolute value of negative 6 is going to be 6, right? So we're going to get I equals 6 minus 1. That's going to be 5, right? So again, we went out of bounds, right? That would be somewhere over here, but that's out of bounds, right? So, and we know this would never be the solution anyway because it's too big. So, okay, and then we're going to go to the last value. Again, we found a 3, right? So we're going to go to I equals 3 minus 1. That's going to be 2. We know index 2 is going to be over here. So, and we're going to change this to a negative, but good thing for us, it's already negative. If it's already negative, we don't want to change it back to a positive number because remember, 3 does appear in our list. Just because it appears twice doesn't mean we want this to be positive. We still want to know in constant time that 3 exists in the input array. So we leave it negative. So then one last time, we're going to be iterating not through this loop. Now we're going to be iterating through this set. So we're going to be iterating through 1 through the length of the input array A, right? So that's also going to be an O of n operation, right? Basically the length of this input array. So we're going to start for n equals 1, right? We're going to take 1. We want to compute the index, right? So we're going to take 1 minus 1 is going to be 0, right? So we want to know, does 1 exist in our input array? We can check that by checking the 0th index of our input array. If it's negative, that means 1 does appear in the input array. If it's positive, which in this case it's positive, right? This is positive 3. That means n equals 1 does not appear in our input array, right? Therefore, n equals 1 is the smallest positive integer that does not appear in our input array. Awesome, right? That's the solution. We did that with 3 loops, but it still ended up being big O of n. There's one last edge case that I'm going to show you. Notice how this value was originally a positive 6, right? But we changed it to a negative 6 because we still wanted to know what value was originally stored here, right? So we could take the absolute value and then convert it to a positive 6, right? We wanted to know the original value. But we also wanted it to be negative so that we could indicate that a positive 3 exists in our input array, right? But my question to you is, what if the value that we're changing, for example, what if we had one more value in our input array and it was a 2? Then we want to mark that 2 exists in this input array so we can compute I equals 2 minus 1. That's going to be 1. So we're going to go to the 1 index value in our input array, right? This is index 0. This is index 1, right? So now we want to mark that we want to change this to a negative value to mark that 2 exists in the input array. Hold on. This is a 0, right? But we don't like changing the value. We just want to multiply it by negative 1, but it'll stay 0. So what value can we change this to? For example, if I just change this to a negative 1, right, a negative 1 value, we can't do that. Why can't we do that? Because then we're changing the input array. Remember, this negative 1 will eventually, we're going to take the absolute value of the negative 1, right? And then basically we're assuming that a 1 exists in the input array, but originally there never existed a positive 1 in the integer array. So we can't change this to a negative 1. If we do that, we change the solution of this input array. So we have to change it to a negative value that does not affect the solution. But remember, the solution set could only be from 1 to the length of the input array. So if we change it to supposedly negative length of the input array plus 1, right? So basically we're taking length of the input array plus 1 and multiplying it by negative, right? If we do that, we're not changing the solution set, right? Well, actually, technically, this could be a solution, right? This would be the worst solution that it could possibly be, the greatest value it could possibly be. But notice with this value, it's out of bounds when we compute the index of it. So basically, this is a good default value to give it because we're never going to be marking that value as showing up in our input array because it's always going to be out of bounds. That's basically the point that I'm trying to make. So that basically handles all the edge cases. So if we found a 0, this is the negative value that we would give it to. Otherwise, we would just take that positive value and then multiply it by negative 1. So with all those edge cases being said, now let's actually jump into the code. It's going to be 3 linear time loops. So remember the first thing.
Yo, I'm taking my little break. I guess the goal today is just to understand this problem. That's crazy. I'll be back to do a bathroom. What? I have to sub to you 2 weeks ago, so I need push-ups. What the fuck? What are you talking about? How am I even supposed to understand this problem? Like, what? If I could solve this and understand it, a Boolean array? Like, that's not, it's probably some open shit. Oh, I don't know. That's probably why. Hmm. This is some like crackhead ass solution, bro. Bro, this is insane. Taking my 10-minute break, fucking nah, G. Oh shit, no. That was criminal. Oh man, getting fried in that game was sort of like. Sir, you're gonna have to leave. Get out of here. That wasn't bait. Maybe it was bait, bro. That had to be a bad move. This guy's kind of not that good. That's not too good. That is not too good. If I go here, that's just not very good. I'm getting absolutely bum rushed right now. I thought he was trash at the game. I started getting shit on. It's like the story of my life. Watch out here. Retard. It's animated. Oh. Yo, I don't know. I'm kind of silly, bro. Anyway, my brain's not functioning right now. Why is it talking like this? The cursed part is crazy, ChatGPT. It's crazy if you want to less than N. Two over X are gonna work. Index X minus 1 is present. Okay. I mean, yeah. Then turn I plus one. Yo. Zero, one, two. It's kind of complicated. 0, 1, 2. I really get 3. There's 1 in there. Reject 2. Goes in there. Reject 2. That was painful. There's no way I spent 30 minutes trying to understand that. If I could code this up one time, I'm getting off for today, bro. I mean, Habib won. What do you mean? Yeah, why? I feel like so many random people. What kind of question is that? It's so random on some like computer science channel. Motherfucker saw it. You were just people are still watching that? I didn't even know. That happened so long ago, like 2017 or something. I like Habib better. But I don't know, he's been doing too much crypto scamming. I don't know. It's a little strange. It's your first time chatting? Right now. Actually, I don't know. Are you guys new? Are you new? I'm in a very precarious predicament. Very no good. Am I cooked, bro? Yeah. Wait, I'm retarded. Oh my god. You're gonna draw at me? No way. It's a little silly, little munchkin. He wants to draw? He declined after fucking doing that shit? Now he wants to draw. Yo, fuck you. I'm fried. All right, back to the game. No, okay, okay. Fuck me, dude. Shit my pants. Wait, I need to relax. All right. If it's in pounds, let me see. And then minus 1 equals 7. I think this makes sense. Else you just change it to if. Else it could be like really like negative 80,000 or something. You don't have that index. Zero then. Can't even do nose of I minus 1. Oh man, fucking mental gymnastics here. So it gets to 0. According to my solution, we do a 0, 0, 0. They'll loop through and say, what happened here? Scan through a second time, check nodes. Nodes are I minus 1. It was 0. That's negative 1. I can't just change it to negative 4. Does that mean that we found what the hell? So what would even happen here? That's kind of an issue. Look again, we'll say I don't think we should do that. I think we should change them to zeros. Maybe I don't think if we encounter a 0, I think we just continue. Yeah, I don't think there's some issue with this, like, oh wait, hold up, I wrote it here. I don't fucking know, dude. It's just complicated shit. kind of butchered the fuck out of this. This goes all the way up here. Oh, brother, this is 8s. I have no clue, bro. If nums of I is less than. If nums of I is. But this is like. This is the low of insanity. This is kind of weird, bro. That works. It's not gonna pass. Like the 2. 0. There's like an error here. They have 4 problems I need to fix. Oh. Oh, yeah, that's a problem. Because I'm indexing first and then I might go out of bounds. Okay. Nums of I plus. You're saying I don't need this because What's some big ass number? I minus 1 equals 0. Numbers of num minus 1 equal. Wait, what? So if it's in between this range, like it's like between 1 and n minus 1, then nums of I minus 1 is going to equal the negative version. If nums of I minus 1 is 0, then nums of what, this is I? Um, if num minus 1 equals 0, then nums of num minus 1 equals negative 4. This actually works? Motherfucker. Yeah, I thought it was going to be inside this other if statement. I was like, mm. The current number is between 1 and n. That means it has a variable. We're doing minus 1 to convert it to negative. If it's greater than 0, nums of num minus 1, if nums of num minus 1 is greater than, didn't this already assume that it's greater than 0? Oh, we're not checking minus 1 there. We check that the indexed at the value. So this is checking if the index in nums is greater than 0. So it's like a number that's valid. If it is, now we check, hey, is that number greater than 0? Like positive. If it's positive, then motherfucker, I don't even know, bro. So if it's greater than 0, I'll tell you which parentheses go to what. I feel kind of fried right now. This alpha S should go there. Like that. So if it's a number, and if the number is positive, then you flip it. If that number happens to be 0, which means it was a negative originally, we're still going to mark it. Okay. Bro, I don't even know. One typo away. Num is a value in array anywhere from. If num equals n, then never went to index. Holy shit, I'm retarded. If the num is greater than 0, I don't know why I didn't know nums. Because this is like, we're checking if our index is valid. That was depressing. I'm so not interested in designing a hash map right now. Or some. I don't want to sell this shit. I think I'm done for today. My brain's kind of fried. Yeah, I'm opening up Liza P, bro. You got me here wilding, playing some video games. Bro, I forgot to play this game. Please. I spent today doing this BS. Just 240 minutes. $4 hours? That was what 4 hours feel like? Oh my god. Yeah. What's going on, Leet?
Hear all about your experiences, but now isn't a good time. Use this. We'll catch up.
So is that what they want me to do? I feel like I've been here before.
So about that weapon assembly tool you were talking about. If you find any more weapons, let's try using them here.
Switch Legionnaire assemble weapons? Okay. Assemble new weapon. I don't think I have anything. Probably level up. I'm sure I got something. A technique. Hell yeah. I know I'm gonna die, like why not? What does this change? I don't know what any of that does really. Damn it. I don't really want to walk through these guys. Aha. Yo, man. Figaro. Ew, hell nah. The guy sees me? Nah, right? I'm not fighting him either. Oh my god, yo, chill, blood. Fuck, asshole. Crazy. Destroyer's amulet. got my amulet. It's gotta be in my bag. Yeah. Increases match HP. Increase damage inflicted on puppets. I feel like I like more damage, right? I feel like this is where I die, probably. Probably where I get my shit rocked. 20, I don't know, I'll do like 75 for now. What the hell is this? I think it's a boss. It's definitely a boss. Oh, it's a hotel. This is low-key so cool. Good movie. Yo, this is insane. The scrapped watch, man. Yo, chill, blood, chill. I only got full HP. It's kind of messed up. Yo, that's crazy. Oh no, I'm cooked. The timing is terrible. Oh my god. Oh, yo, his stagger step's insane. I can't mess with that. Alright, he wrecked my shit, bro. I just got humiliated. Oh, I should have opened this door. I felt like that, like, so you don't have to walk through this shit. I think they let me take damage, right? Yeah. Yeah, watch it be like you can't see the enemies around. Alright, alright, they're not that cooked. Alright, we're gonna go cook some, what? Do me get a job. Yeah, bro. Stupid ass puppet, bro. Dumbass puppet. That is insane, bro. You're cheating. You can't do that, bro. It's not right. No wonder they scrapped you, little homie. Silly guy, bro. Silly guy. Oh, wait. Yo, wait. Chill. Wait. How do you do that shit? Yo, that's insane. I don't know how to do it. Bruh. How do you long attack? Yo, he's actually insane, bro. Yo, this thing just flew, bro. Does that do damage? That probably does. Knowing this game. Oh no, that actually does do damage. I don't know. Alright, so. You're actually fried, bro. Alright. You Sebastian, brother. That shit was not cool. That was not cool. That was very not cool, brother. Very not cool. You're lucky I didn't know how to hit the first one on you. Lucky boy. All right, mother lover, mother lover. Yo, bro was a freak in long ass lanky arms, man. I'm dead. Whew. I'm a fluffer. Why you use that shit? You know, that's kind of rough, bro. You absolutely. You're gay, bro. 1, 2. I'd be embarrassed, bro. Whoever made you should be embarrassed. You suck. Couldn't run. Yo, my stamina used to be. Yo, you gotta be so conscious of your stamina, bro. Or you're like fried. That was not cool. That was so not cool. Is that base or not, bro? It's like, is that good? Niggas really be studying 8 hours. Pretty fun, probably. That was painful, you know? That's the last time I'm going in. I got that buff. Can I beat this boss? Yo, fuck you. This nigga's insane, bro. Bro, that's like cheating. You get to like perfect parry, damn. I'm just getting shut down by this guy, bro. I'm getting shut down. I gotta hop off, but like, I'm getting shut down by this nigga, bro. Probably be back for some more like programming later.